Hey Chioma, how we doing? Let's see. Let's see. Let me turn this down a smidge. Quack, 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 All right. Good evening. Good evening. Good evening, Chioma. Good evening, everyone. How's everybody doing this fine evening? Hopefully, everybody's doing well. I know it's 4 o'clock. It's already evening time. Good, good, good. Just got a simple section to do today, so not a whole ton to do today. I promise you that. But we'll get it knocked out of the way. My internet really messed with me last time. What happened? Was your Wi-Fi or internet not really working last time? What happened? Sounds like it was pretty messy. Let's see if I can find that thing. Stream kept going off. Oh, yeah, that would be a problem. Now, I've had issues in the past where my stream kept going off, but I've since resolved those issues quite a long time ago. I'll have to rewatch the video. That's fair. You can rewatch the video. That's fine. It's here on the channel. I have to upload it to YouTube still. If you want to watch it on there, it'll be like another. I'll probably upload it tonight or something. But yeah, you can watch it on this channel. That's fine. Everything on this channel archived for 14 days after the initial broadcast. So. Whoa! Hey, Gemma, thank you for the 35 bits. Hey, Gemma, you're so nice. Thank you. Just popped it out. You gotta shoot off. Oh, thank you, Gemma. That's so kind of you. That's super nice. Thanks for the 35 bits, Gemma. You're amazing. Hey, Pistache, good evening to you. Hello, hello. Yusuf, how we doing, man? I said hello earlier. How we doing this, what time is it over there? Oh, it's evening time for you over there. So, very deep in the evening. 9 o'clock. How you doing this fine evening, Yusuf? It's a little early in the evening here, but, it's pretty, probably pretty dark out there. Hopefully you're ready for this weekend. A couple more matches on the way. All right, everybody. We're going to get started here in a few minutes. We'll wait a few more people to come on in and we'll get going. We got a simple section just to knock out of the park, and it shouldn't be too hard to do. Just a little bit to do, but not too bad. Hisa, good evening to you. How are we doing today? How are we doing today? I hope we're doing good. What's the temperature? Oh, it's pretty cold. It's about 0. Actually, it is 0. It is 0. So, yeah, it's 0. It's 0C right now. Things are starting to get pretty cold here. I'm good. You? Yeah, I'm doing very good, Hisa. Doing very, very good. It's been absolutely fantastic so far. Fantastic. We've been doing all right. How about hopefully we got plans for this weekend, doing some stuff, I don't know. I have no idea. I'm going to bite the bullet here, guys. Something very important is going to happen next week. I'm going to go clothes shopping next week. This is a very scary endeavor for me. I'll try to keep myself sane. Fair. That's very fair to say. I'm gonna go clothes shopping next week on Saturday. I know. That's the only time Mom and my sister want to take me out clothes shopping. I'm like, okay. I'm like, this is gonna be a little hard. I haven't been proper clothes shopping in a while. So I think when's the last time I went clothes shopping? Oh my gosh. How many years has it been? 6, 7 years? 6, 7 years? Yeah. I want LP sees you at the game and she shocks you. I mean, I'll be happy to see LP at the game. I'm gonna try and make it, Yusuf. I'm gonna try and make it. That's the goal. The goal is to try and make the game. I can't give you any guarantees, Yusuf. It depends if my flights get on time and I arrive on time. The biggest hurdle to that is I gotta land, I gotta take a flight, and I got an hour and a half between layover, and I gotta hop on my next flight, and I better hope that nothing goes wrong. So, and I'm not late. So that's what I'm kind of hoping for, and I can get that stuff out of the way. Where am I going? I'm going to England in December, if everything goes well. Cross my fingers. So I'll be going to England in December after the semester's over. So pretty much right after the semester's over, I'm a gone a little over 3 weeks. So I'm gonna spend the majority of my vacation there. This is like I rarely go on vacations, so it'll be nice to just kind of have a little bit of a change of pace, and to see my good buddy Yusuf out there, along with a whole host of other people that I'm sure. I hope they're looking forward to seeing me. I hope so. But if not, that's okay too. But hoping to take in watching a lot of hashtag football naturally, and hopefully to see the sights in and around London. Eat some good food. Our ticket price is expensive. I paid like for the round trip. I paid like 1,100. Again, ticket prices are gonna be more expensive around December time. To be fair, right? I mean, Christmas time. That's just gonna be more expensive than other times. I'm sure if I picked a time, like in the middle of February on a Wednesday, those prices are gonna be like $600-700. But not many people are going to England in the middle of a Wednesday during the school year, for example. So that's not as often. So, but yeah, it was about 1,100 to go take a round trip. So, and I got a Airbnb, and I'm going. Yep. I have some relatives there. Yeah, actually, it's kind of weird. I do have relatives in England, out of all places. I don't even know. Look, yeah, if there's one thing you guys got to understand about me, I haven't met all my relatives, and I don't think I ever will meet all my relatives. That's not how it really usually goes. So, my relatives are everywhere. Everywhere. And I mean everywhere. So, my dad had, my mom's side of the family has, 4 brothers and sisters together there. My dad's side of the family had 7 brothers and sisters. And, yeah, he was the second youngest amongst his 7 brothers and sisters. My dad's in his 70s, and stuff like that. So, it's like, there's a lot of first cousins that are much, much older than I am that already have families and already have grandkids. And I've never met in my life. I'm not gonna lie to you. There's a lot of people there. 100% that I've never met before. Oh, the relative train, it goes really wide, and so apparently I have, according to my father, I have relatives in Birmingham and in Gillingham. So that's what he says. I have relatives there, so I'm gonna probably go visit them and to see what's up. So visiting another side of the family is kind of nice, especially when you haven't explored one side of the family too much. You've always wanted to go to Egypt? Yeah, the Egypt sounds really nice. I'd love to go visit the Great Pyramid of Giza. That's an engineering marvel, man. I would love to go visit there, that's for sure. Gotta have me some Egyptian food. That's number 2. Egyptian food. I can't go wrong with Egyptian food. There's only one type of food in the Middle East. I know Egypt is technically part of Africa, but there's only one type of food in the Middle East that I would probably never eat again. Probably. That's Saudi Arabian food. Saudi Arabian food, man. Saudi Arabian food is not good. Okay, it's just not good, guys. Please. Saudi Arabian food makes me sad. There's just absolutely no flavor in Saudi Arabian food. Oh. You gotta have flavor in your food. If there's no flavor in the food, it tastes like cardboard to me. It tastes like cardboard. At a Saudi Arabian roommate, man, oh my gosh. This tastes like cardboard. Anyway, ladies and gentlemen, enough talking from me. Alright, well, maybe some more talking, but still. Alright, let's do this, ladies and gentlemen. Let's do some intros. Let's get going here. Let's get to it. Let's see what do I do. Alright. Okay, let's get started with today. Welcome back to Thursday. End of the week time today. So today, we are doing section 4.3, okay? We are almost there, folks. We have this section and one more section to go, and then we are done. So by the next class here on Tuesday, next Tuesday, we will be finished with the textbook. Okay, that is the story. Okay, that is not too hard. Alright, and so today we are going to be going over one more, another part here that we haven't looked at. Let's refresh here for just a second. We took a look at R, okay, which is the linear correlation coefficient. We've also seen the line of best fit. Now today we're going to be looking at one more thing here that is going to be on our agenda, and that is going to be what we call the coefficient of determination. Okay, so let's take a good look here and talk about what the coefficient of determination is and see exactly how we can deal with that. Alright. I need to bring the book. There we go. Bring that here. Do this. Alright. Let's take a look at number 1. Some of these things are going to be things that we've already talked about before. They're not going to be anything brand new, in all honesty. So, nothing too crazy going on there. Let me erase this too. This is music houses. Alright. Or YouTube videos. I gotta remember to erase all that. Gotta stop watching Bull's videos. So sad last night. Anyway, I digress. Alright. Okay, so let's take a look at number 1. What are the explanatory and response variables? Okay, so explanatory and response variables there. First of all, we've already talked about explanatory and response variables. First and foremost, X values are going to be the explanatory variables. The Y values here will be the response variables. Again, we discussed this before. In the very first section, here of this chapter, we said, all right, hey, I plug in a value in for X. I'm going to get some values back out for Y. Okay, that's going to be my response after I put in some kind of input. Now, let's talk about the main meat and potatoes here. And that is, what is the coefficient of determination? Now, the coefficient of determination explains how well the line of best fit works with the dataset, i.e., how well the variation in the residuals is best explained by this line of best fit. Now, we talked about the idea of residuals last time, okay? And we said, okay, the residuals here are basically take the observed value and subtract it, and subtract the model value here. And we can see whether or not that happens to be, overestimating, underestimating based on the model compared to our actual data set. All right, and so we actually have a metric for it here to see exactly how much of the data set can actually be explained by the line of best fit, i.e., how many data items in the data set would be within, say, the margin of error of what the line of best fit is going to kind of give you, if you kind of want to call it that way. So, if we take a look here at number 3, it'll help explain exactly what that means. It says, what does the coefficient of determination mean? In a more formal sense, it measures the proportion of total variation in the response variable that is explained by the line of best fit. So the notation here is what's a little bit more important here. Let's talk about said notation. Now, notation here says it is r squared. Okay, r squared is the notation here for the coefficient of determination. So if r squared here was 0.9614, for example, I just made up a number here of 0.9614. Let me put that in bold there. Then I would say 96.14% of the variability in y is explained by the line of best fit. That's basically it. So any of the variability, if it's overestimating, underestimating, 96.14% of the data set is basically falls within that kind of pseudo margin of error that the line of best fit would provide. Okay. Seems pretty legit. Okay. Right, any questions about that so far? Any questions? Okay. Alright. So far, so good. Alright. Now, you're probably wondering where we are going to go with this. There will be a purpose, I promise you. Alright. Nope, alright. Now, let's take a good look here at number 4. Alright, we talked about number 4 here before when we looked at, say, R, okay? When we looked at R, we said, alright, is there a relationship between... Is there a linear relationship between X and Y, whatever X and Y meant? So, I asked this question here once again, how do we determine if a linear model is appropriate, between, say, an X and a Y? Right? So you say a linear model is appropriate if the correlation coefficient R, this is just going to reiterate here, shows a moderate to strong relationship between both variables with a good coefficient of determination. So if we have a good coefficient of determination, pretty high one, and we have a strong to moderate to strong, kind of relationship, whether that be a moderate to strong positive or a moderate to strong negative, then that would indicate that a linear model is very appropriate here. And we have different ways to model that. We have different ways to kind of measure that out. Now, having said that, of course, what I would like to look at next is I would like to look at a couple of problems, okay, a couple of examples. Let's actually put it to the test here. All right. Let's take a look at this here. We're going to look at number 15. Okay, we're going to look at number 15. We're going to talk about exactly how we can find some of these values. All right, and we'll see exactly how we can met this out. I'm going to put this over here to the right because I am missing that here. So go ahead and bring up, you guys could go ahead and bring up the calculator here. All right, so what I would like you to do now is go ahead and take out your calculator here. Let's go ahead and go through this one more time just to see how we can get r squared. Once you have your calculator out in front of you, I would like you to write cheese fries in the chat. Write cheese fries in the chat once you have your calculator out in front of you. All right. Hopefully everybody has their calculator here. Okay, Anna's got the calculator ready. Good. Gioma too. All right, everybody's good with the cheese fries. Excellent. Nothing wrong with some cheese fries, let me tell you. All right. Anyway. All right. So first things first here, ladies and gentlemen. Let's go ahead and put in. We're going to do number 15 here. Number 15. So we're going to talk about another old faithful geyser and Calistoga. Actually, have I been there before? I think I have been there before. Oh, okay. I think I stopped on the way over there when we actually were just roaming around Napa Valley. Oh yeah, okay, I've been there. Anyway, I have the time between eruptions, which is here in minutes, and then of course the length of eruption, which is here in seconds. All right. So let's go ahead and go to stat. We'll go to edit. If we have some lists in here, again, we want to clear them. So highlight the list, hit clear and enter. Highlight the list, hit clear and enter. We're going to enter in all the values we see over there for X. Okay, so let's do that. Okay. Alright, so here are all the values for X, and we'll put all the values for Y, which is the length of the eruption in seconds. Oops. 1, 3, 2 threes. Alright. Alright, once you have all your numbers entered into the calculator, please type Italian beef into the chat. Please type Italian beef into the chat once you have all your numbers in your calculator. Okay, Jake and Big Chimpin are good. Type Italian beef in the chat if you have all your numbers in your calculator ready to go. We'll move forward once you guys do. Someone wants Portillo's. What? I may have to say somebody got Portillo's, you know. That's my inspiration is drawn. Somebody had Portillo's for lunch. I'm just saying. See, if I just say, hey, I got it, you know, I'm like, you know, that's kind of boring. We gotta throw out different words out there, you know. That's what we gotta do. All right, everybody's got Italian beef. All right, Italian beef. Gally's got Italian beef. Excellent, excellent. Good, good. All right. All right, so here's what we have here. All right, everybody's got the numbers entered in. Let's go ahead and do the next part here. We're going to go ahead and put in, we'll hit the second in mode key here. We'll get to the main screen here. Just make sure we don't enter anything bad into our lists, okay? So let's go ahead and hit the stat key here. All right, I want you to go over to calc. Okay, we'll go over to calc. And we're going to go to, again, number 4, linreg AX plus B. Okay, so again, want to linreg AX plus B. Again, for what we did here previously, we want L1, comma L2. Okay, so for those of you who have the old school calculator, again, just as a reminder, second 1, comma second 2, L1, comma L2. Again, we come back to this guy. Again, it should default to L1, L2 for the X list and Y list. But if it's not there, again, second and 1 for L1 and second and 2 for L2 if they're not there for whatever reason. You should leave the frequency list and this other thing alone. Just leave those blank. Make sure that there's nothing in there. And then go ahead and hit calculate. Okay. So, this is what we should come up with here. Alright, so let's... I would like you to copy paste this word in the chat. if you have copy paste this word in the chat. If you have the same answer on my screen as you do on your calculator. Copy paste this word in the chat. Very good. Good. So far, so good. Hopefully we got a few more people here that got it good. Excellent. Hopefully, if you're having trouble, let me know. All right. So now that we have our word here. By the way, that's a real word. That is a real word, by the way. I'm just going to point that out there. Pneumonal ultramicroscopic silicovolcanoconiosis is a real word. Okay, this is true. Not very hard to say. It's pain to spell, but it's true. It's hoping for chocolate cake shake. Instead, you got pneumonal ultramicroscopic silicovolcanoconiosis. That's what you got. You got lung disease instead. A lung disease. Congratulations. Very, very good. Okay. So let's take it. I'm sorry, Anna. Alright, so let's take a good look here at our result for number 15. So for number 15, we have an r squared here, specifically of 0.8298. Okay, so 0.8298 is what we get here for our result for this problem. So essentially, what does this mean at the end of the day? At the end of the day, this effectively means that 82.98% of the variability, and let's go ahead and put some context to this, of the variability of the length of eruptions is explained by the line of best fit. Alright. Alright, there we go. Perfect. Okay. And that's essentially what r squared is going to be here in this particular case. Alright. It doesn't seem like there's a much more, but there is. There is a little bit more. We need to talk about that. But this is how we can effectively find r squared here. Again, in the same exact area we found the slope and y-intercept and our correlation coefficient here. Alright, so there we go. We got it. Perfect. Alright. Questions so far? Any questions? Alright. Let's take a good look here at the next example. Alright, so I'm going to pick actually this direct book example so you can get a preview of the homework problem here for this. Let's bring it up here. Alrighty. Okay, so let's go ahead and take a look at this here very carefully, alright? Now, we know how to figure out what r squared and r is, that's fine. But I think looking at some homework problems, at least going over some of these questions can give you good insight about how to do some of these. So let's take a look. It says the following data represents the time between eruptions and length of eruptions for 8 randomly selected geyser eruptions. Okay, so just like we did here. Now they said, what type of relation appears to exist between the time and length of eruptions? Now we need to look at the scatter plot here. So here's the scatter plot. So let's have you guys answer the question here. Is this going to be A, B, C, or D? What kind of, gonna kind of compile a lot of the things we talked about the past 3 sections here. Do we have A linear positive association of positive? Do we have a negative, a nonlinear pattern, or no association? What do you guys think? A, B, C, or D? Alright. The answer is A. That's correct, okay? Absolutely positive association, 100%. Alright? Good. Now, here's the next part I want to talk about here, because I haven't talked about this yet. Does the residual plot confirm that there's a relation between time and eruptions and length of the eruption here? Let's take a look here. This is the second thing that you see here. This is the residual plot. Now, I want to talk about this here for just a second. Now, how do I know that a linear relation actually exists, or at least confirm that there's a relation that exists? Basically, here's how it works. It works just like this. If there is no pattern in the residuals, that means that the linear model is appropriate. So if there is no pattern, and I do mean no pattern, if there's no pattern in the residual chart, slash scatter plot, then a linear model is appropriate. So this is one of those things that probably you would want to write down. If there is no pattern at all. Okay, if there was a pattern, then we'd have a problem, because then you would get further and further away, or you get further and further away, either too positive or too negative. You don't want a pattern. You want it to hover around 0, right? 0 would mean that the model is extremely accurate, but you don't want an actual pattern in reality. So, if I were to pick A through D, A, B, C, or D, which one would you choose based on what you see here on the screen? Would you pick A, B, C, or D? Alright, Jake says D. Let's see what others have to say here. Jimson says D. Clay says D. Anna says D. Pistache says D. Isa says D. Alright, so everybody's saying D. Alright, so we'll get D here. We'll check that. And that's correct. There's no pattern here that we see in the residual plot. So it is what it is. Alright. Now this is a silly question, but it's still a question that they ask here in this type of question anyway. The coefficient determination is found to be 93.4%. Provide an interpretation of this value. And we just talked about the interpretation here. It says the least squares regression line explains 93.4%. You just put 93.4 again for reasons. Alright. Of the variation. And you always want to pick y. So whatever y is, that's what you're going to pick. The length of the eruption. So again, it's always the variability in y. So whatever y is representative here, that's the thing that you want to choose here at the end of the day. And that's going to be your guy. And so we pick that, and we're good. Alright. Good stuff. Alright. Questions so far? I'm going to do another example here, but any questions? Yo. if you have no questions, type Anna's chocolate cake shake. So if you have no questions, type Anna's chocolate cake shake. That's I am merely I'm merely commenting on something that you do not have. The answer being no. There is no Anna's chocolate cake shake at the moment. I mean, in the near future, there may be an Anna's chocolate cake shake that, you know, you may have in your hand. That may be a thing. Just not at this moment in time. Okay, good. Alright, let's do another one together. We'll do number 17 together. Alright. I'm gonna skip a few parts here, but you'll see. Alright. Can you see that is the question? Maybe not. See if I can make that a bit bigger. Alright. I just need that half there. Okay, there we go. Alright. So, let's take a good look here at what we have. We have the following data represents the number of calories per serving and the number of grams per serving. Okay, for a random sample of some high fiber cereals. Complete parts A through D below. Alright, got calories, you got X. Got sugar, we got Y. Alright, so we got some calories, we got some sugar. That's great. Alright, now, here's a scattered diagram here, as you can see off to the upper right-hand corner. Alright, so what kind of relationship appears to exist? We have A, B, or C. What do you guys think? A, strong linear, strong non-linear for B, or little to no relationship for C. What do you think? A, B, or C? What do you think? A, B, or C based on this data? A, B, or C? C. Lisa says C. Clay says C. Pistache says C. Anna says C. C for chocolate. Okay. The answer indeed is C. There is no discernible pattern here. It looks like just an amalgamation of 5 points that just kind of sitting there. But they don't really make a line or anything like that, not like the last example. So there's not really a pattern there. And there we go. Alright, now you can find the correlation coefficient. The correlation coefficient is, again, we can find that via the calculator. We do it the same way we find R squared. I'm going to kind of skip this part here because you guys know what to do. I want to focus on a couple of the parts here. So, alright, so here they give us a correlation coefficient of minus 0.267 here. Dash 1262. Do I want to become famous? Man, I know the answer to this question, so does everybody else. You're about as famous as you are in the list of the band pool. Alright, very good. Oh man, the spammers that come out in force. Alright, next. Determine the critical value for the correlation correlation coefficient. Now, if you recall here, sorry, this is kind of listed below here. So what you could do is there's an icon, there's a table here of critical values that we can actually see here. All right, remember that's dependent on how many of the how many of the sample size are going to be. So we have 1, 2, 3, 4, 5 of a sample size. Remember this table that we had here in the back of the book we talked about before in the very first section of chapter 4. So we looked at n is equal to 5. We see that we have a critical value here of 0.878. So that's what we're going to put here for this. We'll hit check answer for that. And that's fine. Okay. So try the next one here. Now, is there a linear relation between calories and sugar content? Okay. So, what do you guys think? A, B, C, or D? Is there a linear relation between calories and sugar content? And we talked about this back in the first section of this chapter. So let's see if you guys remember what I did in that first section there. So, A, B, C, or D is, what do you guys think? Is there a relationship between, a linear relationship, excuse me, between calories and sugar content based on our values? Oh, I see the answer. All right. You say A. All right. You guys remember what it took to be a linear relation here? There's one thing I'm going to have to remind you guys about, because this is, again, another section it appears in, so that's why I wanted to go over this example, just to be on the safe side for you guys. Just remember how it works. Here's how it works. Remember, you have to have the... Oops, sorry. You have to have the absolute value of the linear correlation coefficient. Okay, it has to be bigger than the critical value. Remember, that's how it has to work. Alright? So in this case, positive 0.267. I changed my answer to C. So not a bad change at all. So 2.267 and 0.878. That's what we have to look at. Now, obviously, 0.267 is less than that. So we would say, obviously, no. So the answer is indeed C. Chioma, Jake, Jimpin, you're correct. Since the absolute value of the correlation coefficient, that's this one we have here in the first part of part B, is less than the critical value, there is no linear relation between calories and sugar content. Alright, fine. Check that, and that's okay. Okay. We'll continue. Okay, so now what they decide to do is they say, okay, well, let's add another thing to it. Okay, they said, all right, let's add another thing to it. This says 50 calories and 3 grams of sugar per serving. All right, to the data set. So they actually add one more point here, which is 50, 3. So we just want to first line up the graph here. So this is the let me go ahead and shrink this down here for a second. This is the initial graph that we have, the scatter plot. Now we want to look at the new scatter plot, this time though, with 50, 3 put in. So if we take a look here, 50, 3 is going to look like, which one of these is going to be our winner? Well, it's going to be probably C. Okay, we have calories on the bottom, sugar on the left. And again, we have 50, 3 over here. So that's going to be our answer for this. Click on this, that would be good. Give me a second. I got this to work before. Alright, hang on. I need this to work. Buddy, it'll work for me. Work for me, please. That would be very helpful. Is there a radio button for this? Okay, there we go. I just had to click on C. Alright, so let's click on C. We check this. This is okay. Alright, next. Okay. Now you can find the new correlation coefficient by plugging that into the calculator just to give a bit more. I'm not going to really get into that again. I'll leave that to you. I'll just guess wrong here on purpose. Okay. So, What is the new critical value here? Now, this one you guys can't answer for me. What's the new critical value? If we add one more point, what's the new critical value? What is the new critical value here in this problem? We added one more point here, so what's our new critical value here in this case? Remember, we had 5 points before. We had 1, 2, 3, 4, 5. We had added one more. And so that's correct. Very good, Shioma. That's right. 0.811, right? Because we had 5 points before. Now we added a 6th point. So our sample size is 6. We want to look at that Arba, that guy right there. Good. Good job, everybody. Okay. Now we want to compare. Alright, so now let's compare. Is there a linear relationship between calories and sugar now with the new point? Okay, so is there a relationship now? So, there wasn't before, but is there now? So A, B, C, or D, which one would be your winner here? A, B, C, or D? What do you guys think? Would it be yes? Would it be no? What do you guys think? A, B, C, or D? So A says yes because it's greater than. B says yes because it's less than. C says no because it's less than, and D says no because it's greater than. All right, everybody's saying A here. All right, everybody is correct. Good. The answer is indeed A. Good. So adding that one extra point, pretty big deal. Okay. Now the last one, one of the last ones here is, we're getting there. Is the new point an influential observation? So basically, since we added the point here of 50, 3, right? We basically want to say, since the variables now appear to be linear related when they weren't before we added the extra point, there's evidence to show that the new point is influential. Okay, it was very influential. We went from it being never related to now adding the 6 point here, which magically somehow made it related again by some reasoning. Okay, especially by the numbers that we were given. So click on that, and that's fine. Let's look at letter D here. Why is it necessary to show a scatter diagram with the correlation coefficient when claiming that a linear relation exists between two variables? So a lot of this has to do with influential observations. So it can pretty much do everything. It can cause the correlation to decrease or increase substantially, or again, it can give insights to values outside of the data range. So the data may appear linear when they're only linear for a specific range. So the answer to this is going to be D, all the above. It can increase, decrease, or affect it very wildly if you have extreme values. Alright. Okay, and that's all we need to do for that example. Alright. Very nice. Any questions? Any questions, guys? Any questions? No? Okay. Alright. So that, in a nutshell, is pretty much the end of section 4.3. That's it! Yay! That's all I'm going to have you do. You guys can do the stuff on the calculator. Again, you just go into the well here once again to find what r squared is. And yeah, that's it. That's it for section 4.3, ladies and gentlemen. Nothing more to really say outside of just doing the homework. But, yeah, that's it. So, that will take care of it for today, everybody. Thank you, guys. You guys are fantastic. Remember, come on back on Tuesday. There's going to be a big announcement on Tuesday. All right? It's going to be a big announcement on Tuesday, so I'm just letting you know now. Big announcement on Tuesday. Very important. Bum, bum, bum. All right? All right, big announcement here on Tuesday, but we will hold off on that until we finish the last section, which we will. I will talk all about that on Tuesday. So you'll have to wait for the test, the testing stuff here. I will be discussing on Tuesday. So come on back for that time, and I will give you all the details. Every single detail, I will give it to you. All right? I will give you everything. All right? All right. You know me. I've always been transparent up to this point, and I'm not gonna about to change now. So I will tell you everything you need to know, but I would like you to wait until Tuesday, once we finished everything up. Then I feel it'll be an appropriate time to talk about that. All right, everybody. Thank you so very much here for coming on out here to the stream once again. All of you are absolutely fantastic people. Thank you so very much. I love all of you guys. You guys are fantastic. You guys will make this class fun. And I will see you all next week, next Tuesday. Next Tuesday, we'll be back, okay? All right. Have a wonderful evening, everyone. Again, as always, everybody, like I say, stay safe, stay healthy, but most importantly, stay sane. All right? Take care of yourselves, everybody. Peace, Pistache, Chimp, and have a wonderful evening, really. And hopefully have a wonderful weekend, okay? Have a wonderful weekend. Anna, have a wonderful weekend. Thank you very much. Go get yourself your chocolate cake shake you so deserve. All right? Gally, have a wonderful one. Chioma, thank you very much. You have a wonderful weekend as well. Thank you, everybody. Take care of yourselves, and we'll see you later. See you, everybody. Bye! Bye, Chioma. Yeah, you better get your shake. Get your shake on, Hannah. Go get a shake. Tell me how it was next week. All right? Tell me in its caloric, delicious intake. All right? You're vegan? You know what? Cheat day. Fine. We'll see you later. We'll see you later. Take care, everybody. Have a great one.